You're crouched in the dark, and it is not the dark you know. No streetlight leaking through curtains. No phone glowing on the nightstand. Just black. The kind that swallows your hand 6 inches from your face. Somewhere out there, something is moving through dry grass, and you cannot see it, and it can probably see you. This is a Tuesday night, 300,000 years ago, and there is no fire. Right now, you probably have a phone that lights up a room, a thermostat that argues with the weather and winds, a stove that turns on with one twist of a dial. None of that existed for the vast majority of the time humans have walked this planet, and yet people survived, raised children, and passed on everything they knew, in total darkness, in brutal cold, facing animals that could kill them in seconds. So how did ancient humans survive without fire? Not how did they discover it, how did they live before they had it, and how did entire populations get by in places and eras where fire wasn't reliably available at all? In 2012, archaeologist Francesco Berna of Boston University published findings from Wonderwork Cave in South Africa's Northern Cape. Working with an international team, Berna identified burned bone fragments and ashed plant material buried roughly 1 million years deep in the cave floor. That's the oldest widely accepted evidence of hominins controlling fire, but it's also proof of something colder. Humans or human ancestors were already living for hundreds of thousands of years before that point, with nothing but their bodies. So what were those bodies doing instead? Here's where the anatomy gets strange. Harvard biological anthropologist Richard Wrangham has argued for decades that the human gut is unusually small for a primate our size. Our teeth are unusually weak, and our jaws are unusually short. Compare that to a chimpanzee, which needs roughly 6 hours a day just chewing raw food to extract enough calories to live. Something let our ancestors get away with smaller digestive equipment. Wrangham's answer is cooking, but the uncomfortable gap in his own theory is timing. The anatomy shows up around 8 million years ago. The hard fire evidence doesn't show up until 1 million years ago, sometimes later. For 800,000 years, something else had to be doing the work fire would eventually take over. Everyone assumes early humans were simply too primitive to need protection from cold. The truth is the opposite. Their bodies were doing the protecting, with an internal furnace of their own. Researchers studying Neanderthal physiology, including work compiled by anthropologist Trenton Holliday and cold adaptation specialist Cynthia Steegman, point to something called brown adipose tissue, a special kind of fat, dense with mitochondria, whose only job is generating heat without any shivering at all. Modern humans still carry traces of it, mostly in infants and in people who work outdoors in the cold. In cold-adapted archaic humans, it likely ran hotter, longer, and stronger. Here's where it gets strange. Fire wasn't the thing that made humans cold-tolerant. The body already was. That doesn't mean fire was irrelevant. It means humans had a head start most people never picture. Short limbs, broad, stocky trunks, a body shape built to lose less heat per pound than a taller, leaner frame would. That's not decoration, it's architecture. The same reason a squat mug of coffee stays hot longer than a wide, shallow bowl of it. So what filled the other gaps? The ones a furnace under the skin couldn't solve alone? In 2013, paleoanthropologist Lucinda Backwell and colleagues examined bone tools from Swartkrans and other South African sites, dated to around 8 million years ago, showing wear patterns consistent with digging into termite mounds. No fire required. No cooking required. Just a sharpened bone, a food source available year-round, and a working knowledge of insect biology passed from one generation to the next. Termites alone can provide fat and protein density that rivals meat, an entire nutritional strategy sitting a few inches underground, available to anyone who knew where to dig. So what changed? Everyone assumes fire's biggest gift was warmth. Actually, its biggest gift was time. A 2009 analysis by Wrangham's research group estimated that raw plant food can take several hours a day just to chew and digest into usable energy, while cooked starches and proteins cut that digestive cost dramatically, freeing hours that could go toward hunting, tool-making, and simply staying alert to danger instead of grinding through dinner. Before fire, that time didn't exist. It had to be earned some other way, through smaller, more efficient meals, cooperative foraging, and food sources like marrow and termites that needed less processing to begin with. That's the piece most people miss entirely. It wasn't one invention that kept early humans alive in the dark. It was a stack of smaller, quieter advantages, thermogenic fat, a heat-efficient body shape, tool-assisted foraging, and above all, a level of group cooperation that meant nobody had to survive any of it alone. A lone human in that grass, at night, with no fire, is in genuine danger. A group of humans, watching in shifts, sharing food, passing down which plants were poison and which insects were safe, that's a very different animal. You're back in that grass again, and the dark hasn't changed. But look closer now. And it's not empty. There are others near you, watching the same darkness, listening for the same sound, ready to move together if it comes. The real weapon was never the flame. It was the person standing next to you, long before anyone learned how to make one. Humans didn't outlast the ancient night because they were fearless. They outlasted it because they were never really alone in it, and somewhere in trading that closeness for streetlights and thermostats. It's worth asking what exactly got left behind in the dark.